This conference will now be recorded.
Yeah. Hello, all. Good morning. Welcome back. Can you mute everyone? Yeah. Today we are going to discuss about Kubernetes containers and labels, Kubernetes labels, right? Yeah. So yesterday I shown you installation and document also provided, right? So you can try today. Yesterday late night I provided due to some busy, busy activities, right? I could not provide before 8 o'clock, right? So I provide after 9, I think, after 9, after 10, I provide, right? So you can try to install today, okay? The same steps, whatever steps I provided here, the same steps you have to perform. I explain you one more time how to deploy, how to install, configure Minikube. This is the document, right? I provided this document. See here, to configure the Minikube, these are the prerequisites. First, we required Oracle VirtualBox Minikube package. So to install Minikube package, these are the minimum configuration required in your laptop. Okay, 2 CPUs, 2 GB RAM, hardware, virtualization must be enabled. Virtualization by default it will be enabled in your laptop. 20 GB of the free space required, right? So internet connection required, right? So and also kubectl installation required, right? So these are the things required to set up the Minikube. After that, so download VirtualBox using this URL. You can download VirtualBox. Just click on this. I show you how to download VirtualBox. See here. So click on Windows hosts. Click on this. If you have Linux, you can select Linux. If you click on this, it will be downloaded. The step is there here. See here. Click on Windows host. Exe file will be downloaded, right? So double click on that exe file. Once downloaded this, go next, install, finish. That will be installed, right? After that, disable hypervisor platform. So you have to check this. If already enabled this, what will happen? Minikube will not work. VirtualBox will not work. That is why first we have to disable this hypervisor, right? How to disable? Go to control panel, click on programs, turn Windows feature on or off, uncheck the virtual machine platform and Windows hypervisor platform. So where we check that, I show you quickly. Control panel, go to control panel, programs, see here, turn Windows features on or off, click on this. Here hypervisor, see here, Windows hypervisor platform, Windows, yeah, identify foundation 3.5. So this two should be unchecked. If you check this, what will happen? Hypervisor will be enabled. That is why we have to uncheck this. Okay. After that, download Minikube. Click on this URL. Yeah. So once you click on this URL, click on Windows. Go down here. This Windows. Go down here. Here, minikube-installer.exe. This we have to download. Click on this. This will be downloaded. Right. Once it is downloaded, you can double click on that. That will be installed. Go next.
Sir, one question: why do we need to disable the hypervisor?
So hypervisor is one of the virtual model, right? So we are downloading Oracle VirtualBox. So two virtuals at a time it will not accept. Two virtual tools it will not accept at a time. That is why that we have to first one, whatever we discuss here. See here, This one, virtual hypervisor, we have to disable. Then only VirtualBox will work. Or else you can use hypervisor also. You can don't need to download this. You can use hypervisor also. Either hypervisor or Oracle VirtualBox. Right? Yeah. Once install the Minikube, after that, this is the command we have to execute in command line. So we have to open command line as a run as administrator. Run as administrator. We have to open command line. So in that, this command we have to execute so that Minikube will be started in VirtualBox. After that, if you want to check the status, Minikube status, this is a command, right? So after that, so next step here is you have to download kubectl. So if you want to execute kubectl commands, we recommend this. So kubectl means, for example, kubectl get pods, kubectl get nodes, we executed, right? So for which we require kubectl, right? So we have to download kubectl from this URL. I'll show you how to download this. Once you click on that URL, see here, what is this? Download latest release version 1.23.0 kubectl, right? You can download this. Click on this. Once you click on this, this will be downloaded into your login, right? Once it is downloaded, after that we have small process. We have to set environment variables, right? How to set that? So this is the latest version download. See here, once it is downloaded, so we have to copy, we have to create one folder in C drive. In that folder, you have to copy this kubectl file. Once you copy that file into cube folder, after that, so we have to search environment variables in search bar here. Environment variables, right? Open this. So after that, click on environment variables. After that, system variables. Here we have path. One path is there, right? Click on this path. Click on new. Here you have to give the path, whatever path we created here. This path. I gave you steps here. Search environment variables on. Click on environment variables. After that, system variables. Double click on path. Click on new. Copy paste the kubectl path. Now try this command. Kubectl space version space -- client. Yes. So right click on this command prompt, run as the administrator. Now, if you want to check this command, just copy this command. Kubectl is available or not, if you want to check. See here, it is showing version. So otherwise, it will show you red color. If it is not configured, it will show you red color. Now it is configured. Right? So this is the way you can set up the Minikube, right? Yeah. Now, today we are going to discuss about few concepts. Okay, what are those? Explaining. Yeah, first one is Kubernetes containers. Kubernetes containers. Yeah. So basically, what is container? Anyone? What is container? In Docker. Yeah, lightweight environment. It is like a box, right? We can move anywhere. We can use anywhere. That box, right? So it is a lightweight environment. It is a advanced to virtual servers. Container is advanced to virtual servers, right? So currently, project teams are deploying their applications on containers because of lightweight, very faster. right? Yeah. Now, for example, this is my container. This is my container. Okay. So in this, I deployed some applications here. Like, so I deployed some application, right? So this application will depend on some dependencies. This application will depend on some dependencies, right? So this dependencies will depend on container engine. This will be depend on container engine, right? So this container engine will depend on operating system. This will be depend on operating system, right? So normally when we deploy an application, that will be depend on dependencies, right? Yeah, for example, so I have Python application. I have Python. I want to install Python, for example. So this is one of the container. In this container, I want to install Python, right? So Python will depend on some dependencies, right? So dependencies will depend on container engine. Container engine will depend on operating environment, right? Yeah, this we already discussed. Okay, I show you something here. So normally when we deploy any applications, for example, this is my operating system, base OS. In Docker we discussed, right? This is base OS, base OS. So on top of this, we have some virtual layer, or else in Docker image is there, right? Docker image is there. On top of that, normally what we will do, we run containers. You can say this is Docker server. Base OS is a Docker server, for example. Right? So here containers, in these containers, what we will do, we deploy operating environment and also applications, right? Whatever applications you want to deploy here. So these are the lightweight environment. We can move anywhere, we can use anywhere, right? So normally in digital applications, we use this containers. So digital application means Flipkart, Amazon shopping site, Misho, Reliance Trends, right? Those will be deployed on directly containers, right? Fine. Next one. So why we are discussing this? These are very basic things. Okay. Next one, labels. We discussed about labels. What is label? Why we require label? So where we use these labels, we'll try to understand.
Aram, hold a minute here. So application dependencies. Can you explain this one more time? Application dependencies, container engine.
Okay. So normally, this is container, for example. This is container. This is container. In container, what we will do? We deploy applications. So applications will depend on some dependencies. Some dependencies will be there, right? So I show you that. So dependencies will depend on container engine. Container engine is a component in virtualization, in cloud, in Docker or Kubernetes. That will be dependent on operating environment. So this is the operating system, right? Docker server is operating system. This is flow actually. These are the layers. These are the layers. Different layers.
I got it wrong.
Container engine means container functionality. That is functionality architecture. Containerization. Containerization. What is Kubernetes? It is a containerization orchestration tool, right? So that is functionality. Okay. Yeah. Next one. Kubernetes labels. So labels are very, very important. So basically, what is label? Anyone? What is label? Yeah, to identify something, we use we create the labels, right? For example, we have local data center. Local data center. In local data center, we have 1,000 servers, right? In that 1,000 servers, one server is having some issues. So if you want to identify the server, how can we identify? By checking the labels only, right? So when we enter into the data center, we can check the rack label, server label. Based on that only, we can identify. But here in Kubernetes also we have pods, right? If you want to identify the pod, we require labels, right?
Is it like each part will be having label?
Yeah, labels we have to provide. Otherwise, we cannot identify labels, right? I show you practically. I show you. Yeah, labels. So in labels, for example, we have three types of pods are there. For example, okay, like front end. Every application will have three components, right? Front end, back end, and database, right? Front end, back end, database. Fine. So front end, for example, front end selectors will be there. Selectors will be there. Selectors, right? And also environment. Environment. Environment would be production, right? And also team, admin team, and app version 1.0 something. Like this, we give the labels, we give the information to the pod. So normally, while working on any maintenance activity or else any deployment activity, so we have to inform to the respective teams, right? So while informing that, before informing that, so if you want to check which pod is belongs to which project, which pod is belongs to which application, if you want to identify, this labels will help you. Okay, yeah, front end and the back end also selectors will be there. So in this,
What exactly selectors, sir?
yeah, that is one of the component. I'll show you one of the component. So in manifestation, I'll show you selectors will be there. That is one of the component. Okay, yeah, here environment, production, and a team, development team, and app version 2.0, right? So here also database also same. Team, DB team, version, you can say 3.0 something, right? So like this, every pod we provide some information, right? Every pod we provide some information. So when we check that pod, you can easily identify that pod. For example, one pod is down, right? So if the pod is down, when you check the label, okay, this pod belongs to this project, right? So we have to inform to the project, this pod is down. We are working on this pod, we'll update it, right? After that, yeah, once it is resolved, once we resolve the issue, we can revert the event to the respective team, right? Now, so we create some labels here, okay? So I start virtual box here. Just click on this. This is in powered off state, right? Virtual box is in powered off state. Now I want to power on. How can we power on this? Open command line in run as admin. Yeah. So what the command we use? Miniq start space hyphen driver equal to virtual box. So if you execute this command, what will happen? This will be started. Okay, enter this. Now it will be started. See here. See here. Now it is started. Now it is completely. Yeah, it is starting now. Wait for a few seconds. Yeah, now it is started, right? So once it is started, now you can check Minikube status. Here, these are in running state, right? So now it is fine. It is running state. Now I want to create some labels here. So now if you want to check kubectl get pods, for example, see here, these are the pods available. These are the pods, right? Now, so kubectl pod is nothing but, what is the pod? Group of containers. It may be having one container or else multiple containers, right? Now kubectl get pods space hyphen show hyphen labels. So nothing is there here. So your labels app my nginx pod template, that's it. So by using this name, we cannot identify this pod is belongs to which project, this pod is having which applications, we cannot identify. That is why what we will do, so now I create 3 pods with labels. Okay, so how can we create? I show you. Yeah, command here is I want to create 3 pods: front end, back end, and database, right? So command here is kubectl run front end space hyphen image equal to image. I can use nginx only, nginx space hyphen restart equal to No need to give anything here. Space hyphen labels equal to environment equal to prod comma team. I can give team equal to admin team comma app. I can give app equal to version 1.0 comma app version, and also project equal to, I can give some CNA project something, CNA something. Okay. So what I'm doing here, while creating this pod, I am giving labels to the pod, so that what will happen whenever we open the pods, you can easily identify that. Okay. Now,
So what is the part?
pod name is this one, front end. Pod name is front end. So here we discussed it.
Always it will be front end.
Okay. By for example, I'm giving
And
front
then
end.
give any name.
Any name you can give. So I'm just giving front end, back end database for understanding. Okay. Now enter this.
Sir, when you say pod, it contains many containers, right? In different containers, we can host different deploy different applications. Then how do we identify the application name?
App name also can give. App name also can give. App name also, whatever you want to give. For example, I'm giving this. Okay. See here, front end is created here. Front end is created. Right. Now you can check this. Labels you can check. kubectl get pods hyphen show labels. Enter. See here. This is the front end, right? So front end is having some information here, but this is not having any information, right? See here. What is the difference here? You can see, you can observe here. So front end is having app v1 application version 1.0 environment production, right? So project CNA team, which team is working? Admin team is working, right? So you can give other information also here. Just I give few things only. If you want to add project manager, server, project owner name, and also that client name also. Client name already give CNA, right? So whatever you want to add, you can give like this. So that what will happen if the pod is down, for example, pod is having some issues, you can easily identify. Okay, this pod is CNA project pod. When you open this, when you execute this command, it will show you information. So these pods are not having any information. See here. This is simply Nginx application. This is something, a template hash, some number is there, right? Some ID is there. But this pod is having some information. You can easily identify this.
So here, how do we know what are the containers available in the particular part?
That we'll see. Wait for some time. So here, one by one means one container only. One by one means one container only. So if you have two containers, it will show you 2 by 2.
But out of 2 by 2, one can be running, one can be down.
No, not like that. You can run 2 also.
But if one is down, one is running, then it will show 2 by 1. Like.
No. 0 by 1 means 1 is down. 0 by 1. 0 by 1 means it is not working properly. That's the symbol. I show you. I give you some examples.
From where this one is coming up, sir? This is upper command. Where it is given like one container should be created within that part.
By default, one container only available. By default.
Yes, we give number particular number.
Yeah. If you give numbers, will be added. I show you that later. Okay. Front end pod is created here, right? So now I want to create one more pod, which is the backend pod.
Just one more question. Restarts 4 minutes 36 seconds ago, right, sir?
That is the
Restarted that was time ago. But it doesn't mean that it will restart again after 4 minutes. It doesn't mean that. Restarts, it says.
So actually, we started this cluster just now, right? Restarted. So when we stop the mini queue, this contents also will be stopped. Pods also will be stopped. If the server backend server is running, this pods will run.
My question was not that. Restart 4 minutes, 30 seconds ago, right? So it is telling by looking at the restarted, so such duration ago. 4 minutes. It doesn't mean that it will restart again after 4 minutes.
No, not like that.
Because it says it's heading says restart.
Restarts. Yeah.
That's a little confusing. Maybe if you look at it, it seems that every 4 minutes it will restart.
Yeah. Looks like, but it is not like. Okay. Yeah. Next one. I want to create one backend pod. So image I can use Nginx only, restart and labels. Environment production I can give. Team development team I want to give. Dev team and application version 2.0 I want to give. And project, some project name I can give. Right? And also I want to give project owner, right? Owner name I can, something I can give here. Project owner, something, update something. Okay. So enter. Now it is created. So now if you check here status of the labels, see here, backend part. See here, 0 by 1 it is showing, means container is still creating here. Container is still creating. So 1 by 1 means container is working properly. 0 by 1 means container is creating, right? So see here, version is 2.0, environment production, owner information, project name, and team. Which team is working on this? Now this is in running state, right? Yeah. So like this, whatever parts you want to get first time while creating that, so make sure the labels required here. Labels, without labels, we cannot identify. For example, in AWS console, we give the tag names. Every server will give the tag names. If you don't have tag names, how can you identify? You cannot identify, right? That is why these labels will help you to manage all the pods. I create one more pod finally, so which is database pod.
So it is not labels, that's a single.
Yes. Team DB team version 3.0 project. Some other project name you can give, whatever project you want to give. Okay. How to change the labels? Okay, I give you commands. You can try that. Okay, all the comments I provide you. How to change the labels? How to add the existing parts? How to add the labels to existing parts? I give you commands. You can check that. Right now it is created. See here. So DB pod. This is the DB pod. Right. So DB pod, backend pod, front-end pod. We created three pods here. Right. So this is the way normally while creating pods, you can add the labels so that you can easily identify the pods, which pod is running, which pod is having which application, which pod is belongs to which project, right? You can easily identify. Clear, right?
Hello. Even add container to existing projects.
Can you come in? Which?
we can even add container to existing part, right?
Yeah. Yes. Yeah, I give you all the comments, comment sheet. You can try one by one, all the comments. There are so many comments. Right? Clear, right? Everyone?
Hello.
Yeah, go ahead. Yes. Go ahead.
Actually, we are giving these names as manually. Is there any process? Can we get these labels automatically?
In Kubernetes, we can automate, but that licensing required. Licensing should be required. We can automate. Kubernetes currently we are using test lab, mini cube, right? In KubeADM licensing version, you can perform. So at a time, 100 pods we can create. Okay. Existing pods, we can add some containers. Existing pods, we can change the labels. That activities you can perform.
By doing this manually, the time complexity is a bit increasing. By using shortcuts, we can perform.
Yes, yes. Yeah, we can use in real-time projects. We use licensing versions, right? KubeADM. In that, we can perform the automation activities. So next one is persistent volumes, which are storage volumes. Storage volumes. Yeah, this is very, very important interview question. So theoretically, we can understand. So basically, what is persistent volumes? What is persistent volume? So where we use these volumes in real time? So what are the importance here? What is persistent volume? So in Kubernetes, we attach some volumes to the cluster. Why we require these volumes, right? Yeah. In Kubernetes, we have two types of applications are there. Two types of applications are there in Kubernetes. Okay. First one is stateful application. And second one is stateless application. Stateful application, stateless application, right? So these are the very, very important, right? So what is stateful? What is stateless? Stateful means every application, most of the applications, we configure is stateful. Stateful means data will be saved. Stateful means data will be saved. Stateless means no data will be saved. That is the difference here. Stateful means data will be saved. Stateless means no data will be saved, right? So what does it mean? For example, Flipkart application is there. Flipkart application. Back end some storage will be there. So whatever application running on the server, that will be saved in some storage. That is stateful application. Stateless application means data will not be saved. Application will not be saved. But why we require data? Why we require this two? Why we require stateful and stateless? What is the importance? For example, sometimes some
Because some ads will not.
yes, some companies they give some ads 1 or 2 days, right? For example, one product released. For that 1 or 2 days or 3 days, 4 days, they give some advertisements. By the time those applications will be saved in stateless application. Stateless application. In that, data will not be saved in the storage because storage also costing, right? Whatever applications we stored in the storage, that will be costing. That is why stateless applications will not have any storage. You don't save any data in the storage, right? Yeah. Now I show you something here. For example, so theoretically you can understand this. Okay. For example, this is one of the pod. Right. So in this pod, we have two containers. Two containers are there. These are the two containers. So in this containers, we deployed some applications. Here I deployed two applications like /var/nginx and also /var/httpd web server. So here also I deployed two applications /var/Apple application. So here also I deployed some application /var/some hello world application, right? So these applications, if I want to configure as a stateful, I have to attach some storage here. For example, these are the storage volumes, right? So this is the, yeah, like this volume, this is volume symbol. Slice will be there. In the volume, slice will be there. Slice means partitions and yeah. These are the different volumes. This is volume 1. Volume 3. So normally when you want to configure stateful applications, what we will do here? So for example, this is my application, right? So this one I can attach to first volume, second volume, even third volume also. What will happen here? So the application which we attach to the stateful, it should be redundant. What is redundant? Redundancy, duplication, and fault tolerance. Redundancy means fault tolerance. So if one volume is down, nothing will be happen, right? So this data will be saved in 3 volumes. So one volume is down, 2 volumes are down, nothing will be happening, right? So these two applications also I want to configure as a stateful, for which we can attach like this. So that what will happen here? So both the applications, whatever containers we have, all the applications will be saved in the volumes. These volumes are a bit costlier. We use persistent volumes. That is why stateless applications we don't configure in storage, right? So this is very important. In interview, normally interviews will ask you what is stateful, what is stateless. What is stateful, what is stateless? In stateful application, data will be saved. Stateless, no data will be saved. So what is the difference here? They will ask you, right? So normally most of the 99% applications we configure in stateful only. But any temporary applications are there for 1 or 2 days, 3 days. Those will configure in stateless. Right?
But 1 second, one question.
Just a minute. Yeah, go ahead.
So in the storage videos,
Yeah.
Can there be like history, place here, something that is a different?
Okay. This is a Kubernetes storage basically. Kubernetes, inside of the Kubernetes, we attach some storage, serverless storage. central storage. That is nothing but persistent volume. Okay, that we can attach to our cluster. In that, this data will be saved. S3 also provision is there, but not recommended. S3 we should not look at to the cluster. This is having separate storage. Okay. Yeah, go ahead. Someone asking some question here.
Even stateless
Ram?
applications require some data storage, right? Not the persistent volumes. In that case,
Default storage will be there. Without storage, how can we create the application? But data storage, I'm talking about data storage.
okay.
So, for example, in our laptop, without hard drive, operating system, how can we install? We cannot install, right? So, if you want to store any important data, we can connect external storage and we can save the data.
It's like a
Right?
backup, high availability.
Yeah, high availability. Right. Backup copy. Yeah. Another question someone asking. Fine. So this is theoretically you can understand because this will not accept to create this persistent volumes. Okay. So tomorrow we'll work on troubleshooting session. Pod troubleshooting. If any pod is down, how can we troubleshoot? That we discuss, and also one more concept which is networking concept is there, and yeah, we'll see that. Replica set, replica controls are also there. So we work on that tomorrow, and Monday also we work on this. Okay. So Kubernetes, we have GUI also. Okay, Kubernetes will not be completed. Once complete the project, Kubernetes will be completed. So in project also we work on Kubernetes. Kubernetes GUI in graphical user interface. How can we perform the deployments? How can we perform the auto scaling, auto healing, and how can we read the pods? How can we check the pods? We work on GUI also, which is the second project. Okay, fine. Yeah, you can set up a Minikube today. So tomorrow we work on a few activities, right? Tomorrow and Monday we work on this Kubernetes. Right? So later, once, yeah, go ahead. Yes.
I have set up, but I'm getting one error continuously. Like kubectl is not recognized as an internal or external command.
That is, you have to set environment variables that I gave you path, right?
Set that also.
This is the path.
I've set it.
Check once again. I explained, right? So create one folder in C drive. In that folder, you can copy the file and you can open environment variables and you can set the path. Definitely, it will be configured. Okay. So you can try today. So if you face any issues, you can put the screenshot in the group. We'll see that.
Yeah, sure.
Okay. Yeah, once you configure this, you can check this command. It will show you some version. So that it will be so that this is configured properly. Right? You can check this tomorrow. We'll work on different concepts. Okay. Tomorrow and Monday we work on this. After that, we start GCP, Google Cloud. Okay. While working on the second project, again we'll come back to Kubernetes. Kubernetes started completed, right? Fine. Yeah, we stop here. And thank you all.
Ram, are we going to create a Kubernetes KubeADM cluster?
KubeADM is giving some issues. I'm working on that. If it is working fine, definitely I'll show you. Okay. Or else we can work on this, and also GUI also, some other consoles are there. GUI also, shell will be there. I show you in that.
Okay.
Fine. Yeah. Fine. Thank you all.